Hi guys, welcome to the Pepcoding. In this video, we are going to solve Sieve of Eratosthenes. So what question is this? It is a question to find prime numbers, where this is a algorithm to find a prime number in less complexity. So let's see the question. So we have given a number n. This is the range, and we need to print all the primes from 2 to n. And the time complexity for this should be less than n under root n. In level 1 we have find a number, any number is a prime or not in time complexity of O of n, and also we have done to find a prime in O of under root n, so we have done this in level 1, and we will reduce, we will do this problem in less than n under root n, because we have n numbers from 2 to n, and for finding all the numbers is a prime or not, for each number it will take under root n, it will take under root n times, and we have n numbers. So this means, let's say q queries, it will take q into under root n times, where these are the queries and the numbers can be repeated like 2 3 4 10 10 100 again and again, 1000. So these are q queries for finding all the numbers. Let's say all the numbers are n. So finding the number n is a prime or not, it will take under root n time. And we have q queries. This means it will take q into under root n time to find all the numbers is a prime or not. So in this question, for reducing the time complexity, we will do something. What we will do? We will pre-calculate all the numbers from 2 to n, it's prime or not. So it will take some space to save the values of all the numbers is a prime or not. So for this we will use boolean array. Boolean array is prime. The size of this will be, we have given n range, and this n should be included, this n is also included for that range. So the size will be n plus 1, because in array, if we give array of size 10, it will give the size from 0 to 9. But what about this 10? Let's say n is 37, the range should be 38, so this will give from 0 to 37. So we can also calculate the value of 37 also, is it prime or not. So we need to give the size n plus 1 for this boolean prime. Now we have a range n is equal to 37. Let's write the boolean array 0 1 2 3 4 5 6 7 8 9 10, then 11 12 13 14 15 16 17 18 19 and 20, then 20 then 21 22 23 24 25 26 27 28 29 and 30, 31 32 33 34 35 36 and 37. These are the range, and we need to print from 2 to 37. So this is the boolean array having indexes from 0 to 37, and initially all the numbers are true. We are assuming that all the numbers are prime, and we will do some operation to find all the numbers, which numbers are prime from 2 to n, which is n is 37. So initially all the numbers are true, except these two numbers from 0 and 1. Our loop will start from 2, the prime numbers from 2 to n. So initially 2 is a prime number, 2 is a prime number. Here 2 is true. At 2 it is true. So this means if 2 is true, the multiples of 2 like 4, 6, 8, 10, these are not a prime number because 2 can divide all the numbers. So this means we need to unmark all the numbers which are the multiple of 2. Which are the multiple of 2. So here the multiple of 2 is 4, 6, 8, 10, 12, 14, 16, 18, 20, 30, 28, 26, 24, 22, 32, 34, 36. All the numbers are not prime. Now all the numbers are unmarked. These are not a prime number. Now it will go to the next number, which is 3. It will go to 3, and here it will see 3 is true. This means the previous any number before 3 is 3 is not a multiple of previous of any numbers except these two numbers. So this means 3 is a prime number. 3 is a prime number. That means the multiple of 3, again the multiple of 3 are not a prime number, are not prime. So we need to unmark all the multiples of 3, which are 6, which is already false, 9 false, 12 already false, and then 15, 18 already false, 21, and then 24. 24 is already false, 27, 30 is already false, 33, 36 is already false. Now it will go for the next value, which is 4. Here when it comes to 4, it will check 4 is already false. 4 is already false. This means 4 is a multiple of previous any number. So if we want to should we unmark all the multiples of 4? If 4 is a multiple of previous any number, this means all the numbers which are multiple of 4s are already unmarked. Here 4 is the multiple of 2. 4 is multiple of 2. So this means the multiple of 4 is already is also the multiple of 2. So all the numbers which are multiples of 2 are already unmarked. So when we get at any number is false, we do not need to iterate for the multiple of that number. So it will go to the next. So next is 5. 5 is true. This means the previous any number is not a multiple of 5. So this means we need to unmark all the multiples of 5. 5 is a prime number, so multiple of 5 should not be a prime number. So here the multiple of 5 are 10 already false, 15 already false, 20 already false, 25 false, 30 is already false, 35 false. Now it will go for 6. Here when it comes to 6, it will check is it true or not. Here 6 is already false. This means 6 is not a prime number. So multiple of 6 are also not prime number. And if 6 is false, this means 6 is the multiple of any previous number. So multiple of 6 are already false. Here we can see multiple of 6 are 12, which is already false, 18 false, then 24 false, 30 false, 36 false. Now it will go to 7. 7 is true. This means multiple of 7 should be false. Multiple of 7 is 14 already false, then 21 already false, and then 28 already false, and then 35 already false. So this outer loop for checking all the numbers are true or false when we are pre-calculating, this is This is pre-calculation of prime numbers from 2 to n, from 2 to n. So in level 1 we have done to find a prime in under root n, under root n. So the loop was going from I into I. The condition was this. So for this also we have 37. So the loop will go till I into I is less than or equal to 37, that is under root 37. Because we do know the factor, if the n is 36, the factor are 2 into 8, 2 into 18, 3 into 12, 4 into 9, 6 into 6, and same for 9 into 4, and then 12 into 3, and 18 into 2. So we do not need to check again for 18. We do not need to check again for 18 if 2 is already checked for this. If 2 can divide 36, this means 18 can also divide 36. If 2 cannot divide 36, this means 18 also cannot divide 36. So we need to run our loop from outer loop will be go from I into I less than or equal to n till I into I less than or equal to n. And in the outer loop, in the inner loop, we will check if is prime at I is true. If it is true, we will unmark all multiples of that number, multiple of I. So this will be the code. Let's write this. Here we need a boolean array is prime, new boolean of size n plus 1. Now our loop will go from I, start from 2, I into I is less than or equal to n, I plus plus. Now inside this it will check if is prime at I is equal to true. This means we need to unmark all the factors. Unmarking all the multiples of I number. Before that in Java is prime, the boolean is initially filled with false. So we need to fill arrays dot fill with prime with true. We need to fill it with true. Initially all the values are true. Now here we will unmark for int j. J will start from I into I plus I, and it will go till n. It will check till n numbers, and each time it will jump, it will increase by I. And at j we will unmark it as false. So this means if I is 2, all the multiples of 2 will be unmarked as false till n. If 3, all the multiples of 3 will be unmarked as false. If 4 is already unmarked as false, so this condition will not run. And for 5 it will be true, so it will unmark all the multiples, and so on. Now this is the pre-calculation part. Now we just need to print. So printing all the numbers, we will start our loop from 2. From 2 it will go till n, and if is prime at I is true, still the number is true, this means it is a prime number. So here we will system.out.print the number which is I. and with a space. So this is the code. Let's run this. So the n is 10, the range is 10, and we have the answer as 2357. Let's try to submit this. All the test cases are also passed. Now let's take this code to the open board to check how it is taking less time than n under root n. So here this is the code. The outer loop is taking under root n time. Here this will be for I is equal to 2. This loop will take n by 2 times. Each time the j is increased by 2. When I is equal to 3, it will take n by 3. When I is equal to 4, it will take here. When I is equal to 2, it already unmarked the multiple of 2, which is all 4. So this condition will false. So this means it will take only of one time. Then I is equal to 5, this will take n by 5. I is equal to 6, it is also the multiple of 3, it is already unmarked, so it will take 1. I is equal to 7, it will take n by 7 till I is equal to under root n. It will take n under root n time. So the time complexity will be n by 2 plus n by 3 plus n by 5 plus n by 7 plus n by under root n. Now take the n as common. 1 plus 2, this will be like 1 plus 3, 1 by 2 plus 1 by 5 plus 1 by 7 plus dot plus 1 by under root n. So this will be the time complexity. This will be the time complexity of this program. Here if we solve this, it will be equal to log of n, log of n, and there is n multiplying with this, so this will be the time complexity. Now let's take the range of int. It is the range of int. Let's take n is equal to 10 raised to the power 9, or let's take it 2 raised to the power 32. Here 2 raised to the power 32 will be equal to, not accurate, but it will be equal or in range bit near 10 raised to the power 9. So here I am taking n is equal to 2 raised to the power 32. Here in this log they are of base 2, and there is a formula for log of base a of a raised to the power b. This is equal to this b, the power of a. Now we will use this formula. Here we have 2 raised to the power 32 log of base 2 of 2 raised to the power 32. So here we will use this formula of log. This will be equal to 32. The base is 2, a is also 2. So this will be 2 raised to the power 32 log of 2 of 32. And we can change this 32 in 2 raised to the power 5. This 32 is equal to 2 raised to the power 5. So this means it will be 2 raised to the power 32 log of 2 of 2 raised to the power 5. Again the base and the this value is same, so it will be equal to 5. This will be equal to 5. This means it will be 2 raised to the power 32 into 5, where 2 raised to the power 32 is n, so it will be n into 5. If we take O of n complexity, it will be in O of n. We have pre-calculated all the numbers in O of n, iteration of 5. Now if we want to check any number from 2 to n, it will give us is it prime or not. Is prime in O of one time, one time, because we have already pre-calculated. This means this is O of n is less than n under root n. So we have done the solution of this code Sieve of Eratosthenes in less than n under root n. So this is the algorithm of finding prime numbers. We already pre-calculated it, all the numbers. So it will take only of n time, and for the numbers it will take, for any particular number it will take of one time to check is it prime or not. So this was a problem. Hope you understand the approach and the code. We'll see you in the next video. Thank you.